Hi everyone, let's take a look at number 19 on page 83. It can be shown that from a height of h meters, a person can see a distance of d kilometers to the horizon, where d equals to 3.53 times the square root of h. Part A, when the elevator of the CN Tower passes the 200-meter height, how far can the passengers in the elevator see across Lake Ontario? Step 1, copy D equal to 3.53 times the square root of h. Now, before we take the derivative, we write this in exponent form. When you think about the square root of h, that's h to the power of 0.5. Now again, you can write down h to the power of half as a fraction, or h to the power of 0.5 as a decimal. So notice I'm picking a decimal because of 3.53 in the front, which is also a decimal. Now again, for part A, they're asking specifically for how far. So how far means find the distance. Or if you go back to the given, a distance of d kilometers. So again, even though I wrote this in exponent form, this is probably more useful in part B, which we'll look at in a moment. But back to part A, I'm going to plug in height to be 200 meters. So again, height is going to be 200 meters. So I'm going to write down D, which equals to 3.53 times 200 to the power of 0.5. And again, if you took the square root of 200 instead of 200 to the power of 0.5, that's perfectly fine. When I take my calculator and I work this out, this is approximately 49.2173875 kilometers. If my goal is to round this to one decimal place, D is approximately 49.9 kilometers. Part B, find the rate of change of this distance with respect to height when the height of the elevator is 200 meters. So notice in part B, they're asking specifically for the rate of change of this distance with respect to height. So rate of change means find the derivative, which in this case is d prime. You apply the power rule, which means you take the exponent 0.5 and you multiply by 3.53. Again, you can take a calculator. I'm going to do some mental math. If I take 3.53 times 0.5 or divided by 2, that's going to be 1.765 times h to the power of, and again, I'm going to take the exponent, I'm going to subtract 1. 0.5 minus 1 is going to be negative 0.5. Again, if you go back to the given, you want to evaluate this when the height is going to be 200 meters. So I'm going to write down specifically for h equals to 200 meters. This means we want to find d prime of 200, which equals to 1.765 times 200 to the power of negative 0.5. Again, at this point, if you want to take a calculator and work it out, that's fine. I'm going to give you a little bit more. You can rewrite this as 1.765 divided by, instead of saying 200 to the power of negative 0.5, it's going to be 200 to the power of positive 0.5, or the square root of 200. Again, I take my calculator, I work this out. It's going to be approximately 0.1248043,469. And think about the metric. In this case, we're thinking about kilometers per meter. Now think about why this is the case, because if you go back to the given, we know distance is in terms of kilometers, right? So again, kilometers, that's going to be distance. And if you think about the height, that's going to be given in terms of meters. So again, if I round this to 2 decimal places, this is going to be approximately 0.12 kilometers per meter. Let's copy the left-hand side, which is basically d prime of 200. I hope this makes sense.